Ever pondered the shape of our Earth? Is it as spherical as we've been told? A common argument for a spherical Earth is rooted in the theoretical concept of gravity. For centuries, philosophers, scientists, and thinkers have used this concept to explain our world's shape. The idea is simple. Gravity, the force that pulls all matter towards the Earth's center, would naturally shape the Earth into a perfect sphere. It's an understandable conclusion, yet it's based on a series of assumptions, not undeniable facts. This theoretical concept of gravity can be illustrated with a simple everyday example. Imagine an apple falling from a tree. It does not drift to the sides but plunges straight down, providing a manifestation in action. The force of gravity pulls the apple directly toward the Earth's core. Hence, if this force pulls equally from all sides, it's logical to conclude that it would create a spherical form, right? This is the line of thinking adopted by those who endorse the idea of a spherical Earth. However, let's scrutinize this theory a bit more. If our Earth a flawless sphere, we should not witness such drastic geographic variations. Mountains, valleys, vast oceans, all these natural formations challenge the theory of a perfectly round Earth. Isn't gravity supposed to mold everything into a smooth, uniform sphere? Yet the observable geographic diversity blatantly contradicts this assumption. We then arrive at the space images of our planet. They portray a mesmerizing blue-green sphere, gracefully suspended in the vast cosmic arena. But isn't it prudent to question the authenticity of these photographs? These images are taken from thousands of miles away, considerably processed and refined to present us with these grand views. Can we place our trust in these processed images? Remember, they're not raw, untouched captures. They're carefully curated and manipulated renditions of our world. And if these processed images are the primary evidence for a spherical Earth, it's understandable to question their credibility, isn't it? In conclusion, the widely accepted notion of a perfectly spherical Earth is primarily supported by gravity theories and processed space images. It's a story we've all grown up with, yet when closely examined, it reveals inconsistencies. But wait, what if there's more to this story? Stay tuned as we delve into the intriguing world of the flat Earth theory. Let's foster an environment of intellectual curiosity and dare to challenge established perspectives. After all, in the pursuit of truth, no stone should be left unturned. Have you ever heard about the flat Earth theory? It's not as outrageous as it might sound. For centuries, we have grown accustomed to the belief that our home, Earth, takes on a spherical shape. However, the flat Earth theory introduces a new perspective that significantly diverges from this widely accepted notion. It suggests that Earth is not a sphere, but is instead a flat, disc-like object. Imagine a vinyl record or a dinner plate. That's the kind of shape we're discussing. The Arctic Circle forms the center of this disc, serving as the axis or spindle, quite unlike the traditional depiction of the North Pole. This radical representation of our planet challenges the foundations of our "what about the edges of this disc?" What all matter from slipping off into the abyss of outer space? The flat Earth theory attributes a critical role to Antarctica here. However, this isn't the Antarctica we have come to know. In this model, it isn't a mere continent situated at the South Pole. Rather, it's portrayed as a massive ice barrier encircling the entire disk, functioning as a natural wall to prevent everything from falling off. This image of Antarctica is akin to the walls of a petri dish, providing a secure enclosure. The theory also presents a different explanation for gravity, the invisible force that binds us, the Earth. It contends that the concept of gravity is a fallacy. Instead of objects being drawn towards the Earth, they are actually moving upwards. The disc-shaped Earth, according to the flat Earth theory, is perpetually ascending, powered by an unobserved force known as dark energy. This upward motion creates what we perceive as gravity. This substantial reinterpretation of our world does away with the spherical Earth model, replacing it with a flat disk, a colossal ice barrier, and an upward-moving force. The flat Earth theory tests our knowledge of our world and extends the limits of traditional thinking. Intriguing, isn't it? Let's delve deeper. Ever wondered why we can see distant skyscrapers despite the supposed curvature of the Earth? Let me paint a picture for you. You're standing on a shore, staring out to the sea. On the horizon, a skyscraper emerges, its silhouette stark against the sky. As per our understanding of a spherical Earth, this should be impossible. The curvature of the Earth should, theoretically, block that view. Here things get intriguing. Flat Earth advocates believe this observable phenomenon dismisses the spherical Earth theory and propose instead that our world is flat, extending endlessly. They argue the visibility of far-off skyscrapers is simply because there's no curve. Consider this. There suggests we're not gazing around a globe when looking across the ocean, but across a flat expanse uninterrupted by curvature. Now, what does the scientific community say? This with explanations around light refraction, atmospheric conditions, and human perception limits. They assert that light can bend around Earth's curvature under certain conditions, making visible what should ideally be hidden. However, Flat Earth advocates dismiss these explanations. They hold that the tangible reality of distant skyscrapers breaching the horizon is undeniable proof that the Earth is flat, not round. It's a compelling debate. On one side, we have established science with its equations and theories, and on the other, an unconventional viewpoint that dares to challenge the norm, backed by simple observations and a generous dose of skepticism. Makes you question what we've been taught, doesn't it? What's really at the edge of the world? A massive ice wall, perhaps? This is not just some imaginative conjecture, but a theory proposed by Flat Earth believers. They propose that Antarctica is not merely a frosty continent at the globe's bottom, but a colossal ice wall encircling the Earth. Visualize a gigantic, icy fortress, extending as far as the eye can span, safeguarding our world's borders. It's a concept that seems like it's been ripped from the pages of a fantasy novel, doesn't it? But to Flat Earth devotees, this is no fanciful tale, it's their reality. The theory postulates that this vast ice wall prevents the world's oceans from cascading off the edge. An intriguing question arises: how has this enormous secret been kept hidden? The answer lies in a decades-old international pact, the Antarctic Treaty System. This agreement preserves Antarctica for peaceful purposes and scientific research, forbidding any form of military activity, human interference, and mineral mining. Flat Earth theorists, however, view this treaty with suspicion. They contend that the treaty's core purpose is not environmental preservation, but instead to guard the Earth's edge. They argue it's an elaborate scheme designed to hide the truth about our world's boundary. Some even that daring explorers who ventured too close to the edge have been either turned away or vanished mysteriously, strengthening the global cover-up hypothesis. This narrative stirs curiosity, prompting us to reconsider our understanding of our world. Regardless of your stance on this theory, its undeniability lies in its capacity to challenge our preconceptions, opening up a realm of extreme possibilities. The philosopher Socrates once said, "An unexamined life is not worth living." This theory invites examination, doesn't it? It's a lot to take in, isn't it? But questioning is the first step towards knowledge.